We just talked about how to find square roots, but now let's talk a little bit about nth roots. So the nth root is very similar to a square root. Now when we found the square root, there was no number on the outside, but there was an implied 2. So that this number is called an index, and that index, if there is no value there, is a 2, which means that's square root. Now a cubed root means the exact same thing a square root did, except we're saying what number times itself 3 times is going to give us the value on the inside. So quite often, the easiest way for us to do that is to take our number, say 64, and break it down and say 64 is 8 times 8. 8 times 8 is, or 8 can break down into 4 times 2, 2 is prime. 4 breaks down into 2 times 2, and those are prime. 8 is 4 times 2, and 4 is 2 times 2. And what I end up with is I have 2 to the 6th, and I'm taking the cubed root of that. So 2 ways to think of this. 2 to the 6th, I can either say, I know that I need a group of 3 things. A group of 3 says take that value out. So notice I have a group of 3 2's, and I have a group of 3 2's. So each group of 3 2's brings a 2 to the outside. 2 times 2 is 4. The other way to think of it is to take 6 divided by 3. So I take the exponent divided by the index. 6 divided by 3 is 2. So I have 2 2's on the outside, and 2 times 2 is still 4. Let's take a look at 121. We already know the square root of 121 is 11. That's a square root, and it's a perfect square. The cubed root of negative 1,000, notice before we couldn't deal with it if there was a negative on the inside, but because it's an odd root, it's okay to get a negative, because in this case, negative 10 times negative 10 times negative 10 would give us negative 1,000. Again, we could use our tree system to help us find that. Let's look at a few of these, and it's going to help to make a factor tree. So that's how I'm going to help you through all of these. For 16, 16 is 4 times 4. Each 4 is 2 times 2. And I know in order to bring something to the outside, I need, in this case, 4 of them. So notice here, I do have a group of 4 2's. That group of 4 2's says I get to bring 1 2 to the outside, and there was nothing left over, and so my answer is 2. You can always double check it by taking 2 to the 4th. So 2 times 2 times 2 times 2, I end up back at 16. Negative 625. Now this is a 4th root. 4th root is an even, just like a square root. So there's no number that I could take times itself 4 times and end up with a negative value. So this one cannot be reduced until we learn that technique. So for now, just don't. This is a negative, but notice this is an odd index. An odd index, it's okay to have a negative because I know that if I take a negative value times itself, say 3 times, I end up with a negative. If I take it times itself 4 times, I end up at a positive. If I take it times itself 5 times, I end up back at a negative, so it's okay. For 243, I need to find some values that go into 243, and I need a group of 5 of those in order to take something out. And so I'm going to start with a 3. I know that 3 goes into 243. Remember that rule is I could take 2 plus 4 plus 3, which is 9, and since 3 goes into 9, 3 goes into 243. That's the rule. So I am going to put a negative 1 on the outside because I know that it's going to be a negative, basically. But at 3 goes in 81 times. 3 is prime, 81 is not. 81 breaks down into 9 times 9. Both of those break down into 3 times 3. 3 times 3. I know I need a group of 5 things, and I have 1, 2, 3, 4, 5. 5 3's and a negative 1, so my answer is negative 3. Again, you can check this by taking negative 3 to the 5th, which in your calculator would probably look like this, and then either a button that's a caret, or maybe a button that's an x to the y or y to the x, and then of course that 5, and you should end up back at negative 343. And then for 64, again, that would be 8 times 8. Each 8 is 4 times 2. Each 4 is 2 times 2. And I'm going to end up with a total of 6 2's, which is good because I need a group of 6. And oops, missed one. I do have a group of 6 2's, and so my answer is 2. Try all of these on your own, then press play to see how you did. So I have 5, the 5th root of negative 32. Again, because it's a negative and an odd root, it's okay, so I'm going to continue. 32 is 16 times 2. I'm going to leave that -1 so I don't forget it. 16 is 4 times 4. Each of those is 2. And I end up with a group of 5 2's, which is what I wanted, so -2 is my answer. Again, you can check it. -2 to the 5th in your calculator does give you -32. 81 is 9 times 9. Each 9 breaks into 2 3's. I know I need a group of 4 of those in order to take it to the outside, so this group will come to the outside. 1 million, 6th root. This one's going to be pretty easy. I know that 1 million means that it's basically 10 to the 6th, so 1, 2, 3, 4, 5, 6. So instead of making a tree, I'm going to say the 6th root of 10 to the 6th. Those 6's essentially cancel because the 6th root and to the 6th are opposites, and so my answer is 10. And last one, 4th root of -1, can't be done right now, not till we learn that new technique.